everyone, this is the presentation of BSCE 1B, specifically Group 5. So now we proceed to Unit 3 of Chemistry of Engineering Materials. In this unit, we will learn about polymers. But before we start, let's talk first about the learning objectives. At the end of the lecture vid, we should be able to describe the composition, properties, and manufacturing of the three groups of polymers. What are those three groups? Number 1, thermoplastics. Number 2, thermosets. And number 3, elastomers. Then number 2, learning objective, we should be able to compare the physical and mechanical properties of polymers with those of metals. So ngayon, dapat at the end of the lesson, we should be able to compare kung ano nga ba ang properties ng polymers sa properties ng metals or any other materials. Dapat mako-compare natin siya. So now, ano nga ba pag sinabi nating polymers? When we say polymer, from the word poly and mer, poly means many, and mer is derived from the Greek word meros, meaning part or unit. So in other words, polymer is a chain composed of many repeating monomer units. Ano yun? Ano nga ba ang monomer units? So ang monomer units, guys, it is a small basic molecule that can bind chemically to other. So imagine niyo yung bracelet na beads. Pagka nakita ka ng bracelet na beads, yung mismong bracelet, yun yung polymer. Then the beads, yung maliliit na beads na yun yung monomer. So sabi dito, ang polymer, binubuo siya ng maliliit na monomer. So, para siya naka-attach sa chain, which is chemically bonded siya, kaya siya naka-attach. Yun yung sinasabi nating polymer. Then, it is said that molecular chains have average molecular weights ranging from 10,000 to more than 1 million grams per mole, created by combining several mers by chemical bonding to form massive molecules known as macromolecules. So yung madaming polymers ngayon, yun yung bumubuo sa isang malaking molecule, which is we call macromolecules. So in this, we also define polymerization. When we say polymerization, it is the mechanism by which small molecules composed of one unit known as monomer or a few units known as oligomers are chemically binded together to form these giant molecules. So yun yung macromolecules, diba? Yung giant molecules. Then, this polymerization, it usually starts with the development of long chains in which the atoms are tightly bound with covalent binding. So, tandaan nyo yun. The atoms are tightly bound by covalent binding. Now, let's talk about plastics. So, bakit nga ba natin pag-uusapan ng plastics? Kasi guys, ang plastic, isa siyang uri ng polymer na nilalagyan lang ng parang halo or mga other materials para makagawa ng plastic. So, ano nga ba ang definition ng plastics? These are materials consisting mostly of natural occurring and improved or chemically manufactured polymers, often containing additives such as fibers, fillers, pigments, and the like, which further improve their properties. Gaya nga ng sabi ko guys, ang plastic, polymer siya na dinadagdagan ng fibers, fillers, pigments para makabuo ng plastic. Then, it is also said that plastics are high polymer glass which can form into any desired shape by heat and strain. O, di ba ang plastic, pagkagagawa ng plastic bottle, iniinit mo na siya, then saka siya ima-manufacture as plastic bottles, kagaya paggagawa ng mga plastic stools. Di ba may mga molder yan? Iinit mo na siya, tapos saka siya imo-mold into that specific object or specific thing. Thus, ano nga ba ang properties ng plastics? Guys, compared sa mga metals and ceramics, ang plastics ay merong low strength, stiffness, and melting temperatures. However, they also have low density and good chemical resistance. So, dun muna tayo sa plastics have low strength, stiffness, and melting temperature. We all know na Pag ginanon mo ang isang plastic bottle, nayuyupi siya. Pag binagsak mo ang isang stool ng sobrang lakas, nabe-break siya. So yan guys, ang plastic, meron siyang low strength. Then, stiffness, meron din siyang low stiffness kasi nga flexible ang plastic, 'di ba? Then melting temperature. So pag ininit mo ang plastic or sinunog mo ang plastic, nagme-melt agad siya. Tapos sabi naman nito, they also have low density. So mapapansin natin ang mga bagay na gawa sa plastic hindi gaano mabigat. Kasi nga they have low density and good chemical resistance. Kaya nga guys, ang mga plastic matagal siyang ma-decay at matagal siyang masira or matagal siyang mag-blend sa nature. Kasi nga hindi kaya kasi nga meron siyang good chemical resistance. Kaya nga pag nagtapon ka din ng plastic, hindi yan magme-melt agad. Dadaan muna ng 1,000 years para lang ma-decompose or mahati-hati ng pieces yung plastic at bumaon siya sa lupa. Kaya yon. Then now, we proceed sa tatlong classification ng plastics. Yung sinabi ko kanina sa learning objectives. Ano nga ba yung mga yon? Thermoplastic, thermoset resins, and elastomers. So, dito guys, malalaman natin kung anong pinagkaiba-iba ng mga tatlong classifications na to. So, sa kasunod ko, i-discuss niya kung ano nga ba yung tatlo na yon.
Let me discuss the classification of plastics based on their behavior when exposed to heat and force. This classification helps us understand their properties and kung paano sila ginagamit in our everyday life. First is thermoplastics resins. Ang thermoplastics ay nagbabago ang kanilang physical state kapag nag-iiba ang temperature. Imagine them like a candle wax or chocolate. When heated, they soften and can be reshaped, and when cooled, they become solid again. This change is only physical, not chemical, kaya hindi nawawala ang identity ng material. Dahil dito, pwede silang i-melt at i-reshape ng paulit-ulit, making them very useful and recyclable. Think of thermoplastics as a long train, made of many connected cars. Each car is a monomer at kapag pinagdikit-dikit sila, bumubuo sila ng polymer chain. When heat is applied, these chains can slide past each other, kaya instead of breaking, the material can be bent or stretched. This is why thermoplastics are soft yet flexible. For example, plastic bags are made from polyethylene, kaya nilang ma-stretch without tearing easily. Thermoplastics can be amorphous or crystalline. Sa amorphous plastics, the molecules are randomly arranged, while sa crystalline plastics naman, the molecules are neatly arranged. Next is thermoset resins. Thermoset resins start as a soft or liquid materials, but once they undergo a chemical reaction, they form a strong and rigid structure that cannot be reversed. Parang baking a cake, once the butter is baked, it becomes solid and hindi nababalik sa liquid form. Once hardened, they cannot be melted or shaped again. They are highly resistant to heat, chemicals, and deformation, kaya ideal sila for durable and high-strength products. For example, epoxy, polyester, phenolic, and silicone resins. Lastly is the elastomers. Elastomers are materials that can stretch significantly and still return to their original shape, just like a rubber band. They can stretch more than twice their original length and still go back to the original form. They may be thermoplastic or meltable or lightly cross-linked para mas maging strong while staying flexible. Inside elastomers, the polymer chains are naturally coiled like springs. When force is applied, they stretch out, and when released, bumabalik sila sa original coiled shape. Because of their stretchy and flexible nature, elastomers are commonly referred to as a rubber.
Compounding. It is the process of mixing virgin plastic with different additives. Basically, pinagsasama muna lahat ng ingredients bago i-shape ang plastic para mas ma-enhance ang strength, flexibility, color, at iba pang properties ng final product. So here are the different additives and their functions. First, we have resins. Resins is the main base material of plastic. Hinahalo ito kasama ng iba pang additives at ito ang nagbabind o nagdudugtong sa lahat ng ingredients para mabuo ang plastic. Next, filler. It consists of added materials like fibers or powders. Hinahalo ito sa plastic mix para mas palakasin yung hardness, tensile strength, workability, and durability ng plastic. Then we have plasticizers. These are small molecules and acts as internal lubricant and improve the plasticity and flexibility of the polymer. Ito yung additives na nagpapalambot sa plastic. Isinasama ito habang minimix yung polymer para gawing mas flexible at mas madaling i-form yung plastic. While waxes, oils, stearates, and soaps are lubricating additives. It is used to improve the finish and reduce the sticking tendency of the plastic to the molds. Lastly, we have coloring materials. These are pigments or dyes added to the plastic. It is used to improve the appeal, impart beauty, and to give UV protection to the finished material. Hinahalo ito bago i-mold para bigyan ng kulay ang plastic. Now, let's proceed naman sa processing of plastics. 1. We have calendering. Calendering is commonly used for the production of continuous films or sheets. The compounding material is run between two highly polished metallic rollers rotating in an opposite direction, while passing through the gap between the sheet is formed, whose thickness varies with the gap. As you can see sa figure, may iba't ibang part ang typical calendering process. First is ilalagay yung raw material such as paper, plastic, rubber, and fabrics sa Benbury mixer. Sa Benbury mixer, ginagawa niyang uniform ang mixture ng mga materials. After mixing, dadaan yung material sa mixing roll A para mas ma-spread at ma-refine siya. And after that, dadaan naman siya sa strainer. Dito, tinatanggal yung impurities like mga dumi or unwanted particles. After that, dadaan ulit siya sa isa pang mixing roll or mixing roll B para mas maging smooth at consistent naman yung thickness niya. After mixing rollers B, dadaan na siya sa calender or yung series of polished rollers na umiikot in opposite direction. Habang dumadaan siya sa pagitan ng rollers, mas nai-stretched at na-flatten yung material or nagiging continuous sheet or film siya. Yung kapal or thickness naman ng sheet is depende sa gap between rollers. Kung mas maliit yung gap, mas manipis yung sheet. Kung mas malaki naman yung gap, mas makapal yung sheet. After that, dumadaan na siya sa cooling section. Dito, pinapalamig yung sheet para tumigas at ma-maintain yung shape. And after that, sa pinakalas naman na ng calendering process, is yung winder, i-roll up dito yung finished product or yung finished sheet.
So the second technique in processing plastic is we call plastic casting. So it is considered as the cheapest technique and it is used for acrylics, polyester, phenols, and urethanes. So it is a manufacturing technique method where liquid plastic resin is poured into a mold, hardened, and removed to create a detailed part or detailed object. So sabi doon, kung saan ginagamitan ng mold at doon inilalagay ang natunaw na plastic resin pagkatapos initin para makabuo ng isang detailed na object. Kalimitang ginagamit ang teknik na ito sa paggawa ng mga laruan, mga bagay na ginagamit sa araw-araw na gawa sa plastic.
Hello everyone, and now I will discuss film casting under processing of plastics. Film casting is a compounded solution in which suitable solvent is continuously dropped on a moving bed. The solvent evaporates and films are obtained. Para mas maintindihan, polymers are dissolved in a solvent to form a mixture called dope, DOPE, which is poured or coated onto a carrier like Teflon or metal belt, followed by drying through solvent evaporation to form a solid film. Cellophane papers and photographic films are produced using this process.
Next, we have the compression molding. When we say compression molding, it is a manufacturing process kung saan it shape plastic materials using heat and pressure. Based on the diagram, the raw material or unpolymerized plastic is placed inside a heated mold or die. Usually, the material is a thermosetting plastic na designed para tumigas permanently after shaping. Next, the mold is closed and high temperature and pressure are applied. Because of the heat, yung material is lumalambot o natutunaw kaya nag-flow siya and completely fills the cavity of the mold. At the same time, may nangyayaring chemical reaction called polymerization which makes the material gradually become hard and rigid. As shown in the diagram, continuous pressure ensures na nakukuha ng material ang exact shape ng mold habang ito ay nag-harden or curing. Finally, once fully solidified, the mold is opened and the finished product is ejected or removed.
Injection molding. Thermosetting polymers in the form of liquid resins are first inserted into a blender and then directly into a heated mold to create a shape. Formation and curing take place concurrently in the mold. This is a common process used in manufacture identical parts of varying size and shapes. It involves melting the plastic granules and then injecting them into a mold under pressure. This process is highly repeatable and precise. It is also compatible with many materials and generates little waste.
Next, we move on to blow molding, one of the processing methods used in manufacturing plastics. Blow molding is a process where a hollow preform of a thermoplastic called a parasol is inserted into a mold. Through the application of gas pressure, the parasol expands and stretches to conform the walls of the mold. This method is commonly used in producing hollow plastic products such as bottles, cans, vehicle fuel tanks, and other similar forms. Let me explain this further. In blow molding, imagine you're inflating a balloon, but instead of air forming a random shape, the balloon is inside the mold. The plastic tube, which we call the parasol, is softened first. Then air is blown into it, forming it to expand and take the exact shape of the mold. That's why this process is perfect for making hollow objects. Think of plastic bottles, like water bottles or shampoo containers. They are lightweight, uniform, and mass produced using this method. One important thing to note is that blow molding is mostly used for thermoplastics because they can be reheated and reshaped easily. This makes the process efficient and cost effective for large scale production.
Good day everyone, I'm Francis Mike Kigaw and I'm here to discuss all about extrusion under processing of plastics. Extrusion is a manufacturing process used to shape plastics by forcing melted material through a mold called a die to produce a continuous shape. This is the most commonly used thermoplastic manufacturing technique. Extrusion can serve two purposes. It offers a means to constantly form such basic forms as shown in Figure 6 and Figure 7. Extrusion provides an excellent mixer for additives in the manufacturing of polymers, which can eventually be shaped using some other tool. A screw mechanism composed of one or two screws or twin screws drives thermoplastic heaters and additives into a die opening to create solid designs, film, covers, tubes, and pipes. Think of it like squeezing toothpaste out of a tube. The shape of the opening determines the shape of what comes out. So, how the process works? Plastic or usually thermoplastic is fed into a machine as small pellets. It is heated until it becomes soft or molten. A rotating screw pushes the melted plastic forward. The material is forced through a die or a shape opening. The product comes out, cools, and hardens into its final shape. So the key idea about extrusion, it produces continuous products with the same cross section. So examples of extruded products are pipes and tubes, plastic sheets and films, wire and cable coatings, plastic straws, and why extrusion is important. Ito ay efficient for mass production. It can produce long, continuous materials, and it can also mix additives to improve properties. So, extrusion is the process of shaping melted plastic by forcing it through a die to create continuous products like pipes, films, and coatings. That's all.
Good day everyone. I will be discussing 6 important kind of thermoplastics. First in the list is polyethylene or PE. It is simply the polymerized form of ethylene. It is rigid, waxy, white, translucent, and a non-polar material. It is a good chemical resistance to acids, alkalis, and salt solutions. It has also good electrical insulating property and susceptible to organic solvents, especially kerosene. There are two types of polyethylene. First is low-density polyethylene, LDPE, and the high-density polyethylene, HDPE. For the LDPE, or the low-density polyethylene, it has branched molecular structure and flexible and tough, while the HDPE has a linear molecular structure, better chemical resistance, higher softening point, greater rigidity, and lower impact strength. So here are some uses of polyethylene. Polyethylene sheets and tubes for domestic use, toys, coated wires and cables, gaya ng nabanggit kanina na it is good as insulator for electricity, packaging bags, bottles, and caps. Next is polypropylene or PP, and it is obtained by polymerizing propylene in presence of Ziegler-Natta catalyst. So here, the propylene, the CH3CH is equal to CH2, is polymerized and became polypropylene, which is CH3CH2 and N. Or, if simplified, it will be C3H6N, where N represents the number of repeating units. So, polypropylene is an isotactic, highly crystalline polymer. It is superior to PE or polyethylene in terms of resistance to chemicals, hardness, strength, moisture proofing quality. And it is the lightest among all high polymers. Fibers of polypropylene are very strong, and hence fibers are used for making ropes, carpets, blankets, bags, apparels, etc. It is also used as packaging material for pharmaceutical and cosmetic products, for making sterilizable hospital equipments, washing machine parts, pipes, TV, radios, molded luggage, color furniture, etc. Best example ng polypropylene is the outer bag of Magic Sarap, as can be seen in the picture. Third is polyvinyl chloride or PVC. Example nito is yung plastic pipe na tinatawag natin commonly as PVC. So yun, ang meaning pa ng PVC is polyvinyl chloride. Yun yung tubo na plastic. So vinyl chloride is the monomer of HCl to acetylene at 60 degrees to 80 degrees Celsius. What is shown in the figure is the structure of polyvinyl chloride. So PVC is a colorless, odorless, non-flammable, chemically inert powder, and it contains 53 to 55% Cl2 and softens at around 80 degrees Celsius. It is resistant to water, light, O2, inorganic acids, and alkalis. Oil, yeah, petrol but soluble in hot chlorinated hydrocarbons. It is widely used plastic. It has high rigidity and chemical resistance but brittle. So it's used in mainly in making cables, water hoses, toys, raincoats, rexine, pipes of petroleum industry, floor covering, refrigerator components, tires, cycles, motorcycles, mudguards, and etc. Next is polytetrafluoroethylene or Teflon. It is obtained by polymerization of water or emulsion of tetrafluoroethylene under pressure and in presence of benzoyl peroxide as catalyst. Teflon has strong interchain forces due to the presence of highly electronegative functions in the regular polymer structure, which give the material unique properties such as extreme toughness, high softening point, high chemical resistance, low coefficient of friction and waxy touch, good mechanical and electrical properties. It is used for insulating motor, transformers, cables, wires, etc. Non-stick cookware is made of Teflon. So, yung mga non-stick pans ganon are the best example of this thermoplastic. It can also be used in manufacturing gaskets, pump parts, tank linings, pipes and tubes for chemical industry, non-lubricating bearing, and to make non-reactive coatings. Fifth is polyurethane. These are a varied range of cross-linked polymers made from two liquids, a polyol and isocyanate. It can be foamed like polystyrene, but unlike thermocol, it is soft, spongy, known as U-foam. It has low thermal conductivity, and it is used as an insulating material in refrigerators. It is also used in making pillows and mattresses. A coating of polyurethane can also be applied over leather, which improves the appearance and quality of the leather, and hence the bags made of this looks attractive and the shoes feels comfortable. And lastly, nylon 66. Polyamides are synthetic polymers having recurring amide groups, which have a structure similar to that of polypeptides. Nylon, belonging to this class, is used for making fibers. Nylon is strong, tough, elastic, and can be dyed easily. Nylon possesses high abrasion.
Now, let's discuss some important thermosetting resins. First are explosive resins. These materials have outstanding properties that make them widely used as adhesive in the paint industry and as insulators in electrical applications. They exhibit strong adhesion to metals, chemical inertness, stability at high temperatures, flexibility, toughness, and low shrinkage during curing. Now, for explosive resins, these are very important in engineering. What makes explosive special is its strong bonding ability. Once it cures, it forms a very hard and durable material. That's why it's commonly used as glue, coatings, and even in electrical insulation. Also, unlike thermoplastics, epoxy does not melt again once it hardens. This is because it forms a crusting structure, making it stable even at high temperatures. Second, phenolic resins. These are rigid, hard, and water-resistant materials. They possess good electrical insulating properties and are resistant to non-oxidizing acids and organic solvents. Although they are susceptible to alkalis, phenolic resins are commonly used as substitutes for metals in applications where high tensile strength is not required, as well as in electrical components like switches, plugs, and heater handles. Phenolic resins are among the oldest synthetic plastics. They are known for being hard and heat resistant. That's why you often see them in electrical components like switches or handles, especially where heat is involved. However, they are a bit brittle compared to other plastics, so they are not used where flexibility is needed. Third, polyester resins. These resins have high tensile strength and good resistance to hydrolysis. They are widely used in the production of synthetic fibers such as terylene and dacron, which are used in clothing and textiles. They can also be blended with wool for making carpets, blankets, and upholstery. Polyester resins are widely used in everyday life, specifically in textiles. They are strong, resistant to stretching, and do not wrinkle easily. That's why clothes made from polyester are durable and easy to maintain. In engineering, they are also used in composites like fiberglass because they provide strength while still being lightweight.
We're going to discuss again, but this time it's all about mechanical properties of polymers. The mechanical properties of polymers describe how these materials behave when subjected to forces such as tension, compression, or stretching. These properties depend on factors like molecular structure, chain length, and temperature. So the key mechanical properties include strength, which is the ability to resist breaking or deforming under force. Elasticity, the ability to return to original shape after being stretched. Stiffness, resistance to deformation under load. Ductility, ability to stretch without breaking. Stress relaxation, gradual reduction of stress over time when a polymer is held at constant strain, as shown in the polyisoprene example. Polymers generally have lower strength and stiffness than metals, good flexibility and toughness, good chemical resistance, lower density, or lighter weight. For example, a band of polyisoprene is to hold together a bundle of steel rods for up to 1 year. If the stress on the band is less than 1,500 psi, the band will not hold the rods tightly. Determine the initial stress that must be applied to a polyisoprene band when it is slipped over this still. A series of tests showed that an initial stress of 1,000 psi decreased to 980 psi after 6 weeks. The computation is based on stress relaxation, where the stress in a polymer decreases over time even if the strain is constant. The formula used is sigma equals sigma naught times e raised to negative t over tau. Here, sigma is the stress at time t. Sigma naught is the initial stress. T is time and tau is the relaxation time. First, the given values are used to determine how fast the stress decreases. Then the formula is applied to find the required initial stress so that after 1 year, the stress remains at 1,500 psi. The result shows that the initial stress must be 1,787 psi. This means the material must be stretched more at the beginning to maintain the required stress over time. That's all. Thank you.
Okay, everyone, for the last topic, I'll be presenting the topic elastomers, or you might hear them being referred to as rubber. And elastomers can maintain elastic deformations for more than 200%. and it can also be reversible. So, polymer chains, gawa sa mga coil na kapag in-stretch mo, in-applyan mo ng force, bibinat, tapos pag binitawan mo, babalik sa original nilang shape. So, there are two types of elastomers, the natural rubber and synthetic rubber. So, una muna tayo, natural rubber. These are polymerized isoprene, or refers to the chemical process where many small molecules of isoprene, the building block of monomer unit, are linked together to form a long chain of macromolecule, which occurs in the latex of various trees. Example ng trees na to is yung Havea brasiliensis. Then this raw rubber liquefies and softens kapag na-heat. To fix this, we use vulcanization. This is the process of compounding rubber with sulfur. Then this sulfur creates crosslinks between the chains para mabigyan ng necessary toughness yung rubber. Then itong rubber na rin na to is yung base for chewing gum, yung pag-manufacture ng chewing gum. Then next, meron tayong synthetic rubber. There are four classifications of this. First is the polybutadiene. It is a relatively low-cost rubber that acts as a toughening material. This added toughness allows the finished product to endure heavy friction and physical impact. Kaya mas maganda siyang gamitin for tires and soles of shoes. Then it is also structural similarity to natural rubber. It allows it to be processed into flexible protective coatings that can isolate electrical currents for manufacturing insulator for wires and cables. Then meron tayong butadiene styrene. This specific copolymer is used because it provides the balanced mechanical properties such as wear resistance and grip. Ito yung mga required for high-stress environments, lalo na sa mga wheels ng vehicles. Then, C. Butyl rubber. Ito naman is highly impervious to gases. This makes it the best material for inner tubes because it can hold air pressure for long period without leaking. Tapos, bakit naman ginagamit for vibration mounts? Meron siyang ability to absorb energy, makes it ideal for reducing mechanical noise and movement in vehicle and machinery. Then last, polychloroprene. Bakit ginagamit to sa hoses and pipes? It is selected for its superior chemical resistance. It can carry corrosive gases and oils that would dissolve or degrade other type of rubber. Tapos, it is durable material that maintains its integrity under constant mechanical movement and exposure to harsh industrial fluids. Kaya mas maganda silang gamitin para sa mga conveyor belts, gaskets, or lining sa mga reaction vessels. And next is yung self-assessment activity. Kaya naman na siguro natin yung gawin after yung lesson na to. Okay. So that is all, everyone. We hope you learn a lot from this topic and we wish all of us good luck in our upcoming exams. Thank you and goodbye.